Are we live? Yeah, it looks like we are live. Hi, everyone. Good afternoon. This is Anupinder Singh, and on behalf of Geeks Code, I'm going to take this particular live session on C++ pointers, and we'll be try to discuss the topic on the basis of uh, on the basis of the beginner level users, right? And side by side, we'll be taking some of your questions in case if you get any doubt on the topic, right? So let's get started. Let me just check. Are we good on the stream? So I'm looking on the left right now because I have a additional screen out here where I can see your comments and the additional things. Great. So that looks fine. And yeah. Okay, so let's get started. So this is C++ pointers we are going to talk about. My name is Anupanda Singh once again, and here you can see my handle that is available on Twitter. So let's get started with the things that we are going to talk about. So the topics that we are going to cover up will be pointer basics. We are going to talk about how we define them, how we declare them, what are the basic operators that we are going to work around with that. That thing will be discussed, and we'll be looking at the operations. That what are the possible operations that we have at the that we have to perform on the pointers base variables, and how we can work it around, and then what are the different type of pointers and how do we manage them within the programming, right? So overall the flow will be like discussion on the concept will be happening, and then it will be followed by the demonstration by using dev C++ or VS Code. So I may use VS Code as a primary ID, and whereas dev C++ just to show you some of the couple of things, right? And the code during the session can be shared with the organizers, and you may get that in the link of this particular video once the recording is on the YouTube channel. Who am I? Just to start with, so I'm a software engineer turned university professor, and now a technical trainer come training consultant at superbitsacademy.online. So I run 2-3 courses for cloud computing based research related topics, and apart from that, I also do trainings in C++ related thing. And if you want to know more about me, this is the link where you can actually go and look at. This is social.anupinder.com/linkedin. That is where you can find more about me as well, right? So coming on to the very basic part, that what exactly is the pointers? So the computer memory is a very important component for doing any kind of relative processing in the runtime, right? So this computer memory, when I talk about computer memory, it's a primary memory. So it is basically nothing more than a succession of memory cells, right? So every memory cell, they are being contiguous, they are being set in a contiguous structure, and they are being used in combination whenever they are being required, right? So when you talk about a single memory cell, a single memory cell is basically of a 1 byte, which is basically 8 bits in the size, right? So that's the smallest unit that we can have in the particular memory, computer memory, right? And each cell is basically represented as a unique address, right? So this is very important when we talk about the addresses. That is the place where we actually start talking about what do you call the pointers and the relevant operations, right? So this is what you get in terms of your particular memory cell related thing, right? So then to represent a larger data, right? Because we said the memory cells are basically of only 1 byte. So represent the larger data, the 1 byte, larger than the 1 byte, the allocation of the consecutive memory addresses are going to be utilized, right? So if we have a memory, and let's say each box is going to resemble me a 1 byte memory cell, right? So this is the 1 byte memory cell. If any particular requirement comes in where we wanted to use more than 1 byte, that is going to take a combination of these particular set of boxes, right? So how do I know what is the basic a requirement, right? So we talk about a char data type, right? So char is basically of 1 byte. So when I say 1 byte, one single memory cell is good enough for that. Whereas if I talk about integer, depending upon what particular computer architecture you're working on, is it x86 or is it x64, 2 byte to 4 byte requirement of the memory is going to be there, going to be required for that particular variable. So in such cases, the contiguous memory locations are going to get used. So if it is 2 byte, only two memory cells will be used. If it is 4 byte, four memory cells are going to get used for that, right? So this is how the combination has been done, and this is all being done by the runtime, C++ runtime, so that the memory locations can be provided to the particular system, right? And that is what is the primary work of C++ runtime. And working with the memory addresses is basically useful in certain specific use cases, and one of the very specific use case is basically a call by reference. If you know how the functions are being called and how the values are being shared shared with the function and brought out of the function, then I think you can appreciate this particular call by reference use case, right? So this is what is the basic about the computer memory, and how it has been addresses. It has contained some addresses, and how, if we require, we can utilize more than one particular cell of the memory, right? So this is what you get in terms of your particular uh, particular computer memory basics, and how the C++ runtime works for you. Now, coming on to the basic pointer syntax. When you talk about the syntax of defining a particular variable, this is one of the very basic thing we generally encounter in C++ programming language, right? So you have a statement which contains int var equals to 5 and then semicolon. So if I talk about this particular thing, int, it's just a data type that defines that, okay, what should be the memory that requirement for this particular variable, which is named as a var. So this is just an identifier that we are using, and this is an assignment operator, and that assignment operator is basically going to work for assigning the value 5 to the variable var. Okay, so this is integer, right? So by default, if I work in 64-bit, it is going to take 4 bytes in the memory, right? So that is what is the instruction is going to tell the runtime that, okay, this particular identifier is required to have a memory location which is supposed to be provided, and that particular memory location should be a 4 byte. So that means how many memory locations are we going to utilize in this particular part? Is 4 basic consecutive memories, right? So that is what you get in terms of this particular set, right? Coming on to the further part, because the variable the pointer variables are also defined in the similar way. In that particular part, what you will find a difference in this definition of instruction and this definition of instruction is that the data type is being provided at the start of the instruction. Then you have a streak operator, which is also known as a dereferencing operator, and then you get the identifier name, and then in assignment operator you are using the direct reference of var along with the reference operator, right? This is the memory reference operator that has been used, and what is the job of this particular memory reference operator is to get the memory address of that particular variable, right? So this is a clear instruction that you should always use to define your pointers into this particular set of in any particular set of program, right? So this is the basic variable definition, whereas this is the pointer based variable definition, right? So this particular thing, if I wanted to elaborate more on the part of the operators, the reference and dereferencing operators are compulsory in this particular instruction, right? If we are not giving that particular set of operators, right, we will not be able to fetch the address and store the address into the memory location, right, into the specific memory location where it is supposed to be stored under the pointer variable. So what these particular operators are going to resemble, so ampersand is is basically what is read as address of operator, right? Is basically an address of operator, whereas a streak is basically read as value pointed by that particular operator, and this is also known as the dereference operator. So it can be said from this particular instruction that the address of var, the address of var is going to be stored in var ptr, which is going, which is basically uh, containing the value pointed by the pointer var, right? So that is what basically you get in that particular case, right? So this is what you get in terms of here, particular basic variable declaration, and then following is the pointer variable declaration. So always keep in mind that any instruction that contains this streak on the left hand side of the equal to operator, and percent on the right hand side of the equal to operator or assignment operator, that means this is basically a pointer declaration statement, right? So just to give you more idea that how this particular thing may look like into the particular memory representation. So this is a myvar variable which contains a uh, 25 as a value. So in comparison to this, I can simply write int my var equals to 25, right? So this is what you have. Then uh, by using the and percent operator, it is going to assign the memory address, right? So you can see this is a memory, contiguous memory. This is the name of that particular memory location, but this is the address of that this myvar memory location, right? So 1776, by using the and percent operator, the value of the memory address has been passed, and that is being pushed into the foo variable. So the foo variable is like int asterisk foo equals to and percent my var. So this is what you can think about the instructions that are being given. Whereas there is another pair of representation is being given, that is for the bar. Now bar is basically a particular variable which is similar to what my var is. So this has been defined as int bar, right? There is no value which has been assigned. Then if we say bar equals to my var, then whatever the value has been stored into the my var will get into the bar, and that is what has been done. So value has been picked up and value has been copied to the bar, right? So this is what is the basic difference between this instruction and this instruction, right? So you can clearly have an indication or representation in the memory that how this particular thing is going to work, right? And that is what we can understand by using one particular specific example as well, right? So here I'm using a VS code. I'm going to create a new a file, include file stream, a basic stuff that we do in our C++, using namespace std, so that I can have the direct access to the standard C in and C out operation. So main is a function that is going to be called in the first place. Let me just save it, and I'm going to save it as a pointer demo dot cpp, right? So just to have a little bit of, I hope now you can see my screen. So here int my var equals to 25. I'm just taking that memory representation, and then int asterisk ptr, or I would say foo equals to, foo equals to and percent my var. So this is what your particular basic instruction is going to be. So this is a basic variable representation, and this is basic pointer representation, right? So this is what we get, right, overall. So if I want to check, okay, so int bar is also there, and then bar is equals to, let's say, my var. I'm going to make it work, right? Now if I want to do a printing C out, right, here I'm going to have what is the value at the my var that we are going to print into this particular place, right? So here I'm going to do my var, and then it is going to work out for you, right? So just to have a separation in the line, I'm going to use endl over here. This is basically a manipulator that we are using to have a separate line printing on the console, right? Then in the second line, instead of value, I'm going to print the address, or I would say memory address at my of myvar. Of myvar is going to be here. Okay. So if I do this only, and if I try to run this particular program, okay, so a lot of time I forget to do one very important thing. All right, so here you can see value at myvar is 25 and memory address of myvar, because I was directly using the myvar variable, it is not going to print me the address, it is going to print me the value. Pardon me, that was just a miss spell for that particular part. So as soon as I use the address operator, you can see it is printing me the address, right? So right now, the particular compiler that I'm using is 32-bit compiler for this particular C++ program, right? So this is the reason why I am getting this X0x61FF04 as an address for that particular malware, right? Now, allow me to print, let me just see out the new line. And what I wanted to do is, I just wanted to show, because we have this particular pointer variable having the address of my var saved into this particular memory location. So the value stored at foo variable is, I am not going to use any %. I'm going to use foo variable, right? So directly I'm referring to foo. No dereferencing operator, just only foo, right? So as soon as I do it, okay, so let me just save it. This is foo, and this is foo as well. Let me just save it. Okay. So yeah. So previously the file was not saved. That's why it was running from temp runner. So here you can see the value at the myvar is 25. The memory address of the myvar is 0x61FF04. And the value stored at the foo variable is 0x61FF04, right? So this is how you simply correlate that the address of the myvar is being stored inside the foo variable, right? So this is what your memory location is going to look like, right? So if I try to give you a representation, so myvar was stored here, and 0x61FF04 and 25 was the value, whereas foo is being stored somewhere here. It is storing the value 61FF04, and it may have its own 0x61FF maybe 08 or some value associated with it, right? So this is what you get in terms of the memory location, right? Now the point is that through foo, how I will be able to access the value of 25. So what we have to do is, we have to use a streak foo with in the cout statement, and we will be able to access that particular value 25, right? So here, just to have a idea that how exactly it works in the memory. So whenever we are doing this particular kind of utilization of pointer variable to dereference to the value for the address they are storing, so what exactly happens is, it's a two-step process. First step is that it goes to the memory of foo variable, fetch the memory address. So that's the first step. So step one is fetch the value stored at foo variable, right? Or I would say address value stored at foo variable. And then step two is going to be reach to the read memory location location and read the content stored over there, right? So this is what you can do. So this is like first step is fetching the value from the foo memory location, and then reaching out to that. Second step is reaching out to that particular memory location and fetch the value 25, right? So this is what is going to be done into the particular part, right? So I'm going to make a copy of this particular statement, cout statement, and instead of this value stored at, or I would say value pointed by foo variable is, and I'm only going to use a streak in the start, right? When I'm trying to use a streak in the start, you will be able to see that the value which is being pointed by the foo variable is 25. Okay, so this is how you are going to utilize the basic access of your pointer variable. All right, so this is the basic thing that you should understand about the foo variable. And last thing which I wanted to show you is that what is the memory address on which this particular foo variable is storing the value, right? So I would say instead of this, I'm going to copy the value. So memory address of foo variable is going to be ampersand foo, right? So as soon as I do this, you will be able to find that it is printing a memory address that this particular foo variable is containing, right? So here, right now, the memory address which has been allocated to the myvar has become 0x61ff08, whereas the memory address of the foo variable is 0x61ff08, right? So this is how you can actually differentiate that how the memory is being allocated to which particular variable and how it is going to be accessed through the ad, reference operator and the dereferencing operator when you are working with the pointer based variable and its management, right? So I think that that thing is clear. If you have any question, please feel free to write in the chat window. Now, next thing which comes in the picture is the memory consumption, right? So when we are utilizing a particular variable, or when we are defining a particular variable along with a data type, what is supposed to happen is, because this program is going to become a process in the primary memory, and when it is going to become a process, it is going to hold certain section of memory so that it can store its values and then process them, and later on, once the process is over, it is going to remove that particular part, right? So when you talk about the memory consumption of pointer variables, it doesn't depends upon the data type, but it depends upon what type of, or what architecture you are working on. So is it 32-bit, is it 64-bit? Depending upon that, you are going to have the size of the pointer variable assigned to that, right? So right now, in this particular part, because this is a 32-bit compiler, right? So on hardware level or on software level, we generally have the segregation as well, because the compatibility can be made through the operating system. So here, if I try to show you the address, I try to show you the memory consumption. So memory consumed by the foo variable is going to be, so we are going to use a particular size of operator, and I'm going to just pass on this particular variable name foo to that, right? So what is the size of operator is going to do? It is going to find out that what size of memory has been allocated to this particular variable, right? And in the similar manner, what I can do is I can also print the size of my particular uh, particular myvar variable as well, right? So this is what we can do. So memory consumed by the myvar variable is going to be like this, right? So in this particular case, if I try to execute this particular program for you, you will be able to appreciate that. Okay, so the program has not executed properly. So here you can see the value at the myvar is 25. The memory address which has been allocated is this, and the memory consumed by myvar variable is going to be 4 byte, right? Just for the clarity, I'm going to add one more thing at the end, and that is bytes. Right? And here also at the bottom, so it is going to be bytes, right? So if I run this again, you will be able to appreciate that we have added the value bytes at the end. So the memory consumed by the myvar is 4 bytes, and the memory consumed by the foo variable is also 4 bytes, right? Now we also know, we might know, right, that if I add on short at the front of int, right, it is going to give me, the memory location with the half size of the integer, right? So this is going to give me a 2 bytes in that particular case. But as soon as I add short in front of integer, what you can see over here is that the line of the pointer variable declaration has started showing me an error, right? And what this particular error is going to be, uh, that because the memory locations are not matching, or memory requirements are not matching, it is going to give me an error. So if I execute this particular one, if I execute this particular program for you, you will be able to find, okay, I think my system is taking more time than it should. But anyways, so you can see it cannot convert the short integer to the integer in initialization. So the basic pointer representation is going to be looking like at this particular part, right? So this is what you get in terms of that the pointer variable that has been declared, the pointer variable that has been declared for the integer can have the type integer, and which has been the pointer variable which has been declared for the short integer should have a short integer data type associated with it. So type should match when you are declaring your pointers in this particular context. So now if I execute this particular program, you will be able to find is that now the myvar is going to get the byte size of 2 bytes, whereas the other one is going to be 4 bytes. Okay, so this is what you get in terms of your overall memory location. Now there is one more thing I wanted to show you, and that I want to display to you by using a dev c++ id, right? So once we are into the dev c++ id, it allows me to have a variation in the types of my particular C++ compiler. So I can use 64-bit. Uh, I can use 64-bit. I can use 32-bit. Right. So when I am going to have the 64-bit, you will be able to see that. Okay. So I need to run this. We will be going to have this as a pointer variable, right? And 8 bytes is going to be the size for that particular foo variable. It is going to work for that particular section, right? So even though my memory consumed by the variable is going to be 2 bytes, my memory consumed by the foo variable is going to be 8 bytes, right? So the difference here is that my underlying architecture, the 64-bit architecture, has allowed me to have the variable size of more than 4 bytes in this particular case. Whereas if I go for the 32-bit, it is going to show me that the memory which has been allocated to my particular pointer variable is going to be 4 bytes, right? So this is what you get in terms of your memory consumption for a particular variable. That is what you get in this particular case, right? So I hope I'm able to make my point clear that underlying architecture for a particular pointer is going to be is going to be dependent on what will be the size of your particular pointer. Is it 4 byte or is it 8 byte? It hardly makes any difference that what particular type of data you have provided, right? So here if I give you let's say a character variable, and if my foo is also going to be a character variable, character pointer for this particular part, and instead of 25, if I put a particular a as a character to this, right, in such cases you will be able to see the memory which is being consumed or which is being given to that particular variable is only 1 byte, but my ultimate variable of the pointer is going to get 4 bytes, and this is 64 bit release. And this is now you can see, as I'm using 64-bit release for the particular compiler, it is going to be 8 bytes of a particular pointer variable that is being consumed for this particular part, right? So this is how you can actually work it out for that particular part, right? So this is where the pointer variable is going to be, and this is how the particular memory locations that are going to be pointed out, right? So purely it is not data type dependent, it's the pointer variable and are meant to store only the memory references. And we have seen how the demo is going to be worked out for that, right? So other part is what so I just want to pause here and want to see if you have any kind of questions for this particular part. If you have any questions for this particular part, I would like to see in the comment section if you have any. Okay, so it seems like no questions. So let me just proceed quickly. So I'll be taking another 15-20 minutes of yours, just to keep it as simple as we can, so that you guys can get started with the particular part, right? So can you use the pointer to reference another pointer? Yes, Charlie, we can do it. So here, as usual, we declare a particular one single variable of integer type, and then we declare the variable pointer variable, which is going to be using the memory referencing operator, that is ampersand. And there is another thing that we have is, this is a double pointer that we can define for this particular part, right? So asterisk ptr2 equals to ampersand ptr, which has been given, right? So this ptr1 is basically nothing, it's a pointer variable, right? So if I want to point a particular pointer through another pointer, right, I can use a double dereferencing operators while declaring that particular pointer, and this becomes a double double reference pointer for that particular part, right? So this is how you can get this particular thing, right? And to dereference, again, we are going to use the no double pointers to do that particular set, right? Then again, the other definition that we can have is like in this particular case, right? So here one variable has been declared and another variable which has been declared over here with the respect of var. This is a simple definition that we have already seen in the previous example. And then if I wanted to have the ptr1 pointed to ptr2, and here you can see there is no double references which are being provided. So this clearly indicates that whatever the address of the var it is going to take, that is going to be provided to this particular ptr var, right? So this is a little bit of different thing. So just to show you it in terms of memory referencing, so here var has been declared, right? The value has been put over here. Let's say this is 0x21, that is the memory address, right? Then there is the memory with the pointer variable. So here we have ptr1, and that is going to get us the address of 0x21, and this is going to be ptr1, okay, and then it is going to be ptr2. So the address of this particular pointer variable is going to be given into this ptr2, right? So this is like referring to a particular pointer in this particular case, and then this particular pointer is going to point out to the exact value to which it is going to refer, right? So this is double reference. So ptr2 is going to refer to ptr1 to access the value of var variable in this particular case, right? Whereas in this particular case, how it has been happening, the var has been given a value 5, and the ptr1 is going to be having the particular variable, and that is going to contain the particular memory address 0x21, and ptr2 is going to have 0x21 itself. So it is also going to refer to this particular variable, and this is also going to refer to this particular variable, right? So this is the basic difference between these two particular examples, that here a pointer is going to first refer to another pointer, and then that pointer is going to take you to the actual location where the value has been stored. Whereas in this particular case, both the pointers are going to point to the same memory location, because we are not using the ampersand here. We are directly referring the value of ptr1 to ptr2, and this can be equals to like int my var equals to 25 and int bar equals to 25 equals to my var, right? So like pointing this particular value directly to the particular bar variable, right? So this is how the things work in the double referencing part. And in the similar fashion, you can have the alternative version for this particular code over here. You declare the variable, you declare the pointer variable, you pass on the value, and then you declare the particular pointer part, ptr2 equals to null and ptr2 equals to ptr1, right? So this is going to point out the value to ptr2, and that is how it is going to work out for that particular case. Okay, so this is how the things are being working out, and that is the case that you work for the particular set, right? So this is very very important thing that you should keep in mind. Then we want to talk about the null pointer as well. Now this is one of the very important concept. If we are taking the null pointer and the if we are defining a particular variable which is not being given a particular reference, right? So just wanted to have a particular thing related through the uh, yeah. So null ptr.cpp, right? So here, if I'm not defining any reference to this particular pointer variable, right? Okay. And if I try to do the printing, cout, and value pointed by the foo variable is pick foo. So here you can see it is no, not giving me any exact value, any exact reference over here, right? So same thing. Now why it is not doing? Because it is right now, because it is into 32-bit architecture based compiler, and that allows us to have it to have a garbage value stored in a particular pointer variable, right? And that is not going to point me to any other value that is supposed to be, right? Whereas if I run this particular thing into 64-bit, right? Let me just paste this on into dev C++ because this gave me a flexibility to do that. So if that is the case, right, here you will find that it is going to give me a error. And that, how do I know the error is there? Because the return of the value is going to be more than 0, right? So anytime when you are referring to a particular null pointer variable, right, in that particular case, the variable is not going to point to any particular valid memory location. So in case of 32-bit based compilers, it is going to point you with the garbage values, whereas in case of the 64-bit compilers, it is going to give you a runtime error. And that is one of the most bad thing can happen in the production to a particular software, right? So using the particular pointer is by a programmer is brings you a huge responsibility in terms of working out with this particular pointer variable usage and referencing and so on, right? So I hope I am able to make my point clear with the null pointer part, right? So any pointer which has been left null is going to give you an unexpected error in the runtime because of the garbage value pointed by the particular pointer, right? So what are the cases when the null pointer are going to be pointed to the null? If you have just defined only the declaration of declaration of the ptr like this, if you have given directly a null a keyword to the particular pointer, if you have given if you have assigned the value 0 to the pointer variable, right? If you have given the null ptr given to the particular pointer, right? So this is how these are the four cases where the null pointer is going to give you a particular problem in this particular case, right? So such is a case for the null pointers and so on. And this is also the reason why we call this particular pointer as a null point as a wild pointer in this particular case, right? So this is what we have as a basic of basics of our a particular pointer, right? So that is what you get in terms of your pointer based referencing and the further part, right? So uh, uh, that is what you get in terms of the basics to get started with the particular set, right? So any queries you have till now? Is there anyone from the organizers on the call? Did you have any queries till now? I would be taking those queries.
I think none of them have any query.
Okay, okay, all right. Okay, give me a second. All right. So if you guys have any queries, that's really great. If you are not, I think this is what we can kickstart with, right? And let's do some practice on the particular key part, whatever the topics that we have just discussed, right? And what we can have is we can take another 2-3 minutes to have your particular queries. If you have any, you can ask on the particular comments section, right? I think, yeah. So any questions you have, I'm really uh, I'll be really obliged to give you all the answers. If you are not having any questions for this particular session, you and did you like this session for this particular length? Please tweet your feedback to my handle @Anupender, right? And I'll be taking the second session soon, which is going to be follow up of this particular session. I'm giving you guys time to do some practice, and within that particular session we'll be looking at that how the particular set of operations you can perform with the particular pointers, right? So I hope that will work for you. So I'm waiting for your comments, if there is any. Otherwise, next 2 minutes I would like to take your leave for this particular session, and we'll be hosting one more after this particular maybe after 2, 3, 4 days. Sunday will be the preferred day, and I'll discuss with the organizers, and then we can take it forward. Right? There are a couple of more things that you can do, but at least just to have an understanding, because this is the session for the beginners, so you can review the session again. You can see what are the different definitions of the pointer variables we have just gone through, and you can practice on them. If you get any questions, you can come up on that second session, and then we are going to do that as well. Right? So Madhvi, I think there are no more questions. So you can take over, and I think we can close the session. So this is the handle where you can share your feedback. This is @Anupender on Twitter. You can give your feedback on that, and yeah. So that is what we have, and other one is. Yeah, so if you like the session or if you doesn't like the session, just let me know on this particular handle. And these were the particular resources from where I've used. So one is Object Oriented Programming with C++ by Balaguswamy. C++.com is the best resource that you can follow for this. Tutorialpoints.com is another one, and Geeks for Geek is also the other set, right? So with that, I take your leave. Thank you very much for joining in, and I hope you do the practice and come back in the second session where we are going to discuss about the different operations that we can perform with the particular part, right? So thank you very much. Bye bye. See you in the next session.